Welcome to a new episode. Bram, welcome. You're going to tell us everything about generics.
Yeah, generics and especially about variants in generics because my experience is that most developers think that's a pretty complicated subject, but once you understand it, it's no problem. So I'm gonna explain it to you.
Okay, tell us more.
Yeah, so first the definition. We have a list of T, we call it a generic type. And you can also say a list is basically a container of contents of type T, right? So we can ask ourselves the question, how does a generic type behave when it's used as a method parameter? So let's see.
Well, how does it behave? Does it behave?
It behaves properly, fortunately, because of course Java is a statically and strongly typed language, and you want to retain that property of the language. So at any time it must be stay type safe. So let's say we have a developer and an employee, and developer is a subtype of employee. We can ask ourselves the question, is a list of developer then also a subtype of list of employee? So when we put both types into a generic type. So let's see. Suppose we have this method, it's called payAll, and it pays all the employees contained in this list. Are these calls allowed in this situation? So of course we have an instance of the finance class and we call payAll on it, and we say we want to pay all the employees. What do you think?
It is allowed.
Yeah, of course, that's allowed. Of course, because we say, yeah, we expected a list of employees here, right? But then in the second call, we say, I want to pay all the developers. Of course, it must be possible because developers also need their salary and they need to eat pizza, right?
Lots of pizza.
Yeah. So, yeah, do you think it's allowed if we just have this method and we put this call on it?
I don't think so.
Oh, well, most people think so because they think, well, developer is an employee, so a list of developer is a list of employees. But you're absolutely right. Yeah, cheers for you. Because your gut feeling says it is allowed, but it's not allowed, unfortunately. Well, fortunately it isn't allowed. I will show you in a few minutes, in a few seconds actually. And the compiler says a list of developer cannot be converted to a list of employee. So we can say a list of developer is not a subtype of list of employee. And therefore we say in our jargon, we say list of T is invariant, which means you have to put that type into it, what's expected, and nothing else than that. But there is a way to make this a bit more flexible because, as I already said, well, developers also need to eat, right? They need
pizza,
their salary. Yeah. But first the question, why is this not allowed? Well, because we can do things with the contents of the container of the list. So it's actually not about, actually the type is list here and not list of employee. For example, we can iterate through it, we can read employees from it, we can call the pay method on it, and we add a product owner to the list. It's perfectly valid in this context. But if this would be allowed, then we could create a mess because a product owner, for example, in this example, could get added to a group of developers.
We don't want no messy code.
We don't want product owners to program, right? Because then we get a lot of spaghetti. And we don't really like spaghetti. We like pizza and lasagna, but not spaghetti, right? So, well, developers need a salary too, so we want to make this code a bit more flexible. We want to be able to pass employees and developers, and we don't care that we cannot write to that list anymore. So basically, we want that list of developer is a subtype of list of employee. We can do this by making the type at this declaration site, so to call, covariant. And we do this with this syntax. We say, hey, it's not only an employee, but it's something that extends employee. So employee, developer, product owner, whatever an employee you want, whatever employee you want. But that puts some constraints on this piece of code, because a write is not allowed here anymore. Because of the reason I told you before, a product owner cannot be on a group of developers. So that constrains us a little bit, but for most use cases, we can do it like this. So write is not allowed anymore, but these calls are allowed now. So we can pay our developers.
And they are happy and don't write code.
Absolutely. And a product owner cannot enter a team of developers anymore. Also, we can say the parameter ES, so the parameter list of the covariant list of employees, is only producing content. So it's only like emitting employees, producing employees, but it cannot consume employees anymore. On the contrary, we can also like reverse this type relationship. We can also say we can make it contravariant. So with this syntax, not extends, but super. And that like reverses the constraint. We can write to it, but we cannot read it as employees anymore. Because it can be anything. It can be an employee, it can be a person, super type of employee, it can be an object, whatever. So if we look at the calls that are allowed right now, of course we can still scale up a team of employees, but we can also scale up a team of persons or of objects. That's no problem. We can still safely write any type of employee to it, but we cannot scale up a team of specific employees like developers. And this team, we call this type of this team contravariant, and the parameter team is only consuming content. And when you are producing from it, so reading, then the best you can say it's an object. So we wanted to scale up a team, add new members, and the team could contain employees and also more general persons like temporary employees, and that's allowed right now. And in this case, we can pass employees and persons, and we can write to those collections safely without breaking stuff. So if you look at the overview in code, this is the traditional finance department without co- and contravariants. Of course, you see here for regular subtyping, when we say the central entity, the central type is employee. So you cannot pay a person, you can pay an employee, and you can pay a developer. And when you want to pay all employees, you can only call it with the employees list, and not with persons, and not with developers either. Same for the scale up, you can still only call it with employees. But when I refactor the finance department to an agile department, then you can pass employees, but also subtypes of a list of employees, developers. And for scale up, you can pass employees and supertypes of it. So now you can see why it's called co and contra, because co means the same direction, and contra means the opposite direction. Compared to the regular subtyping. So that's basically it.
Very clear. Thank you for your explanation, and see you next episode.
Yes, thanks. Bye-bye.